Okay, so we are starting Module 2 today. And starting Module 2, we are actually going to discuss the different types of numbers. Because as you may have not known, there are different types of numbers. And so we have here a list of numbers that you guys are going to later drag into a chart. You're going to categorize the different numbers. But if we look at page 3, we actually have 3 different types of numbers here. So we have a whole number, and whole numbers are positive numbers with no fraction or decimal. An important thing to note with that is that it includes the number 0. The reason that I specify that is because it's not on here, but there are also natural numbers. Natural numbers are all positive numbers, whole numbers, positive whole numbers, but it does not include 0. So whole numbers include 0, natural numbers exclude 0. You then have an integer. So that is a positive or negative whole number. So that should say whole. So there's no fraction and there's no decimal. So an integer is all positive or negative whole numbers. That also still includes 0. So a natural number, the succession goes like this, in that natural numbers can be whole numbers, but whole numbers cannot be natural numbers. So kind of like how squares can be rectangles, but rectangles cannot be squares. And so we have integers, and then next we have rational numbers. So again, the succession moves this way. Rational numbers are positive or negative numbers, and it can include fractions or decimals. Rational numbers are positive or negative numbers that can be fractions or decimals, so they do not have to be whole. But with the decimals have to be repeating. Repeating or terminating. So repeating decimals would be like our 0.3333, and that just goes on forever, right? Like we know there's never going to be another number. It's just going to be 3s forever. So that's a repeating decimal. A terminating decimal is like if you do 0.10 divided by 2, we know that that ends up being 0.05. It does not go on. So there's nothing that goes on after that. That is a terminating decimal because it stops. So in order for it to be considered rational, it needs to repeat or it needs to stop. A good example of a decimal that does not end, that doesn't terminate and is not a repeating, is pi. So if we think about pi actually goes on forever and ever, and it doesn't repeat. So that is a non-terminating decimal that does not repeat. And that would fall under a category called irrational numbers. So right now we're focusing on rational numbers. And we know that in order for it to be rational, it has to be either a natural number or a decimal that repeats or terminates. It can also be a fraction. So you guys in a moment are going to actually put these numbers here into this fun little diagram. So again, like I told you guys, natural numbers can be whole numbers, which are integers, which are rational numbers. So it goes that way, but it cannot go this way. So a -1/2 cannot go here in natural numbers, but it can go in rational. So just make sure that if you put, for example, the number 4 here, that you are also including it in whole, integers, and rational, because again, it goes this way. So I am going to have you guys fill this out as your practice. Irrational is those numbers again that we talked about, like pi. So pi would go here. And also make sure you are paying attention to things like if it's absolute value of 3, the absolute value of -3 is 3. So that actually makes it a natural number. Or if you think about 90 over 3, that actually equals 30. So again, that is a natural number. And notice how I am placing it in every spot. So make sure you are paying attention to the different numbers they are giving you. For example, 4 squared equals 16. If you cannot place it or you don't know where it goes, you may leave that blank or place it in irrational. So what I mean by that is, for example, you all have not learned square roots. And so this one right here would not fall under a rational number. You can put it under irrational.